This is section 6.2, and we start our study of the trig part of the pre-cal course. And we'll cover sections in chapter 6, 7, and 8. And we begin with 6.2, and we start talking about the unit circle. The unit circle is a circle that has a radius of 1. So this length here is 1. The center's at 0, 0. Everywhere around here it's a unit of 1, so you could see that right here you'd be at 1 0, here you'd be at 0 1, negative 1 0, 0 negative 1. Within here we can draw on any point on this circle we can drop a perpendicular, and so we know that this r value is 1 and we have an x and a y value. In the unit circle, if this is theta, then the sine of theta is y over r. The cosine of theta is x over r. And so since r is 1 in the unit circle, we get that sine theta is y and cosine theta is x on this circle. So if I'm looking here at, well, let me go here. This is 90 degrees up here. So the sine of 90 is 1. The cosine of 90 is 0. So we can learn a lot about values for the trig functions when we realize this. So every coordinate pair around the circle is cosine sine. So we could, these are the quadrantal angles that we looked at, and we already said we knew what these were. But then if we go to the smaller angles, at least in the first quadrant, you have these values. And if we were to develop the unit circle and come up with that, we would realize that when you have 30 degrees here and you have a 1, that you're going to have certain values every time you have 30. And so here's 30 degrees. So that coordinate pair would be square root of 3 over 2 and 1/2. So when we begin to know that, we have all of those values. And so like this question says, point P is on the unit circle. Find all the trig functions. Well, if I know that this is my coordinate pair, I know cosine's this and sine is that. So I've got those two. Tangent is equal to sine over cosine. So tangent is equal to this. So I can put 1/2 over the square root of 3 over 2. When I do that, I have to simplify that. So I'm going to flip this one and multiply. So I end up with 1 over the square root of 3. I have to rationalize that radical in the bottom. So I multiply square root of 3 over square root of 3, and I end up with this. So then I have tangent. The other 3 functions are the reciprocals of these. So cosecant, you just flip this, you get 2. Secant is the reciprocal of cosine. You flip that, and I've shown that math here. And tan and cotan are reciprocals, so I did the same thing. I flipped and I fixed it. So if we understand that and we know at least this much of the unit circle, if we were asked cosine of negative 3 pi over 2, well, we should realize that when you're going negative, you go clockwise. So if you start here, there's 180, or there's pi, and this is asking for 1.5 pi, so you're back up here. So cosine of that would be 0. The sine of 45 plus the cosine of 60. Well, once you have drawn out your circle or you're using your chart, you are able to grab those values. And so you have the square root of 2 over 2 plus 1/2. I don't know where that went here. And you just combine it and make one fraction. So there's 2 special triangles that I would say are worth actually memorizing that you should have learned in geometry. And if you've had trig by itself, then you should have known those. So one is the 30, 60, 90, and one is the 45, 45. If we have those, we learned that basic, this is just a template. So opposite the 30-degree angle, we'll put 1. To get the hypotenuse, whatever this number is, you double. So there'd be a 2. And opposite the 60 is whatever the opposite, the short side was, 1 times the square root of 3. So you've got 1 square root of 3 and 2. On the 45, we know that these are the same because this is isosceles, so 1 and 1, and the hypotenuse is that number times the square root of 2. So those would help you with everything on the 30-degree angles, the 60, and the 45. The other thing that I put here was an acronym that I know I used when I taught high school geometry years and years ago, and it was SOHCAHTOA. And I'm sure we made up stories about some Indian legend or some nonsense, but if you can remember those letters, it tells you sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. That will help you remember. So if I said, what is the tan of 30? That's opposite over adjacent. And then you can fix the radical as you need to. I've got some stuff about using your calculator. You do have buttons on there for sine, cosine, and tangent. Let me grab my calculator up here. And let's quit out of that and clear all that business. So we have sine, cosine, and tan right there on your calculator. And then you have to remember that if you're asked to find secant, that's 1 over cosine. All right, so a couple of things. If we want to make sure our mode, mine is in radians, so if I'm working with finding things like this, I want to go to degree mode and hit enter there. So you want to be in degree mode. Now, if we did cosine of 48, you just hit cosine, you hit 48, you hit enter, and you get this 0.669, and you could round it as directed. Most calculators don't have a cosecant key, so we know that cosecant is 1 over sine. So if we're asked to find cosecant of 21, we could do 1 divided by sine of 21. And we hit enter, we would get 2.79. So if you are given your angle in radians, in other words, this pi over 12, we could go back to mode, change that back to radians, second quit, and then if we did tan, and pi is above the caret key, so we can do second and the caret divided by 12 and hit enter, and we get the 0.267, which rounds to 0.27. So that's a quick how to do those on the calculator. All right, let's go look at our problem sets. Before I do that, I want to show you that the blank unit circle, there is a blank unit circle in, should be in our handouts, and you can use that to practice because that's a really good way to start learning that. And then there is also one that is all filled out for you. So that's important. And if we also would take note, I have an A, an S, a T, and a C in the quadrants. Remember that this goes counterclockwise. This is all students take calculus. That's an acronym you can remember, ASTC. All are positive here. Sine and its reciprocal are positive here. Tan and cotan are positive here, and cosine and secant are positive here. So those are just some things that are there for you as resources. So let's go to the problem sets. All right. In a right triangle with legs A and B and hypotenuse C, the Pythagorean theorem states that. We should know that that's A squared plus B squared equals C squared. That's important to know. If XY is a point on the unit circle in quadrant 2, And if x is negative square root of 2, what is y? So first of all, if you want to use your unit circle to help you with this, so if we pull this up, they said we were in quadrant 2 and our x value was negative square root of 2 over 2. So there's our y value. We should be able to grab that and put square root of 2 over 2. So it really would be helpful if you printed your unit circle and use that as a reference. The point on the unit circle that corresponds to theta is x over 2 is p, and what's the circle? So theta is pi over 2. So if we go back to here, here's pi over 2. The point that is there is 0, 1. Select the point on the unit circle that it corresponds to theta is pi over 3. So if we go back to this, pi over 3, here we go. And remember that pi is 180. So think about it. I don't think in radians, I think in degrees, but 180 degrees is pi. So this is 1/2 pi, that's 90 degrees. Pi over 3 is 60. Just divide 180 by 3. Pi over 4 is 45, and pi over 6 is 30. So you're just dividing these numbers, 6, 4, and 3, into 180. So pi over 3, our point would be 1/2, and square root of 3 over 2. And so we choose that. This one says watch the video and then be able to choose which of the following is not a quadrantal angle. So we should really kind of know that without watching a video, but you're here at 0, and then at 1/2, at 1 whole pi, 1.5 pi, and then back at 2 pi. So all of those are on those quadrant divisions, but pi over 4 is in the middle here. So find the values of sine t, cosine t, all of them that relate to square root of 3 over 2, negative 1/2. So if we go back to our unit circle, square root of 3 over 2 and 1/2. So that's a 30-degree angle. All right, that's a 30-degree angle. And, oh, I didn't see the negative there. Square root of 3 over 2 and a negative 1/2. Square root of 3 over 2 and a negative 1/2. We're down here. We are down here. So we have to figure out all the other ones. We know cosine is square root of 3 over 2 and sine is negative 1/2. So we can fill in square root of 3 over 2 and negative 1/2. Now, tangent is sine over cosine. So you're just going to put negative 1/2 over square root of 3 over 2 and do that algebra like we did in the notes. When you do all of that, you get negative 1 over the square root of 3. Once you get these three, you are just flipping. So this is negative 2, this is 2 over the square root of 3, and this is negative square root of 3. And I suspect we need to fix this. We need to fix that radical there. And so that answer should be simplified. I actually looked, and it looks like maybe they're not rationalizing those. That's unusual, but you may not have to, so do that. You would do the same thing for this one, negative 5 and negative 5. So what we realize is that your x and your y are the same thing. So what I've put the work here for this one. So what we know is this is our x and our y, and we don't have our hypotenuse value, and we need that. So r squared is x squared plus y squared. I plugged in the negative 5s, and I end up with r squared is 50. If you take the square root of that, you get 25 times 2, so you have 5 square roots of 2. So this is your r value. Then you have to remember that sine theta is b over r. And so you put negative 5 over that. That reduces to negative 1 over square root of 2. When you rationalize it, you get negative square root of 2 over 2. Since the a value is the same, you get the exact same thing for cosine, which is a over r. And then tan theta is b over a, which is -5 over -5, which gives you a +1. So we've got these first three. For the last three, remember, you are just flipping. So if we had, you could look at it here, you could say, if I'm flipping that, I got square root of 2 over -1. So that's negative square root of 2. That's the same thing, and cotan will be still 1. So you had to get your R value to make sure you were doing that one correctly. Number 8, cosecant of 3 pi over 2. Now you could do that on the calculator, but we remember we can use the sine of 3 pi over 2. If we go to our unit circle, 3 pi over 2 is down here. The sine of that is the second number there, so that's -1. And cosecant, if you flip it, you still get -1. The cosine of -3 pi over 2. So let's go back. We start here, we go all the way here. That's -3 pi over 2. And the cosine of that would be the first number. That would be 0. All right. Find the exact values of the 6 trig functions of the given angle. 5 pi over 3. So if we go to our unit circle and we're coming around here, we see 5 pi over 3 is here. So cosine's 1/2, sine is negative square root of 3 over 2. We can get those two. Tangent is this over this. You do the algebra, and then you'll just flip to get the last three. Do the same thing for 60 degrees. If you go to your unit circle, here's 60 degrees. Your cosine is 1/2. Your sine is square root of 3 over 2. So you can fill in those two. Tan is this over this. Do your algebra, and you should get square root of 3. Then you flip each of these to get the last three. Number 12, if friction is ignored, the time t in seconds required for a block to slide down an inclined plane is given by this formula. A is the length in feet of the base. So A is here. And gravity is about 32 feet per second. All right, so that's built in. Is the acceleration due to gravity. All right, how long does it take a block to slide down an inclined plane with a base A equals 80 and theta equals 30? So here's our formula. Square root of 2 times 80, and then the G is approximately 32. So 32 sine 30 cosine 30. So on top I've got 160. I've got 32 times 1/2, because the sine of 30 is 1/2. The cosine of 30 is square root of 3 over 2. You do not want to use your calculator on this till you get down here. You don't want to do the decimal things. And so we have 160 over 8 square roots of 3, square root of that, and you ultimately get 3.40. Okay. Number 13, if a certain engine, the distance x in centimeters from the center of the drive shaft to the head of the piston is given by the function below. Theta is the angle between the crank and the path of the piston head. So if they find x when theta is 30 and theta is 45. So here's our formula. Here's our formula. All right, so when theta is 30 up here, x of 30 degrees equals cosine 30. Here's the cosine 30 plus the square root of 6 plus 0.3 times cosine of 2 times 30. All right. And the cosine of 60 is 1/2. The cosine of 30 is square root of 3 over 2 plus this. And if you do all of that in your calculator, you will end up with 4.88. If you do 45, you are just substituting 45 for both of those places and going through and figuring out, you should get 4.71. Now 14 asks you to use interactive figures. So I wanted to show you, it says, tells you what to do. Check the sine and cosine boxes, the approximate values, use the T slider to change from 0 to pi of 2, and it's asking you what is happening to the x coordinate and the y coordinate. So I've got, let's see, let's go get that question. All right, so let's just see if we launch the interactive figure. This is what should come up. It said to check sine and cosine and to check approximate values. And it was telling you to go from 0 to pi over 2. Now you can use your cursor and you can do that, but it goes really fast. So I have found that if I use the left or the right arrow to go up, now you're looking at these values up here. Cosine is your x and sine is your y, remember. So if as I go up, what's happening to cosine? Cosine is increasing, and as it increases, what is happening to sine? It is decreasing. So I keep going, keep going, keep going, and about there they get equal. All right, so let's see how that question works over here. So the x coordinate, the cosine was decreasing, and the y coordinate was increasing. The sine was increasing, the cosine was decreasing. And then you can do the same thing with this one, and it's saying to determine the coordinate that also increases from 0 to 1. So check that out, and you should be able to use that interactive figure and come up with that. So I think that gets us started on the unit circle and beginning to think about the different functions on the circle and how that works.